Okay, so we're given f of x as this function here, and we want to find the derivative and then show that there is no max or minimum. Okay, so f prime of x, in doing this, I start off, find the derivative of 2, and that's 0, so I could ignore that. And then I have this part here, this function here, quotient rule. Starting on the bottom, I get x squared minus 1 squared, x squared minus 1. The derivative of negative 3x is negative 3. Subtract negative 3x times the derivative of the bottom is 2x. The bottom gives me x squared minus 1 all squared. And if I simplify this, I get negative 3x squared plus 3. This is a positive 6x squared. And so I'm left with 3x squared plus 3 over x squared minus 1 all squared, which I can also make to 3 x squared plus 1 over x squared minus 1 squared. Now, the second part of this, part A, says show there is no max or min. Well, in order for there to be a maximum and minimum, my derivative has to be 0 somewhere, and it's got to change from positive to negative or vice versa. That's when there is a maximum or a minimum. Well, if I analyze this function here, I know the bottom part of this function is always positive because it's squared. I know this particular factor is always positive because this is squared adding 1. And 3 itself is always positive. So the positive times a positive times a positive means it is always positive. It is never changing signs. Therefore, no max or min. Okay, so going to B part now. This is A. B part says, let g of x equal f prime of x. And let A be the area between g of x and the x-axis where x is between 0 and A. If big A equals 2, find little a. Well, let's ignore the f prime second for a second. If I want to find the area, and I'll switch over to blue again, between g of x and the x-axis, that's simply g of x from 0 to a dx, and that value I know equals 2. I want to find a. Well, I have to find the antiderivative of this, which I don't even know what g is. But what I do know is that g, I'm told, is equal to f prime of x. So if I substitute that in, f prime of x dx equals 2. Now I can do something. I want to do the antiderivative of the derivative. Well, it's got the derivative, then I want to undo the derivative. That means the antiderivative of the derivative is just f. So that means that my original function, which is 2 minus 3x over x squared minus 1, 2 minus something x squared minus 1, 3x. This is the antiderivative of the derivative, and I want to do that from 0 to a, and that value is equal to 2. Now I just going to do some algebra here, plug in my a, so it's 2 minus 3a over a squared minus 1 minus 2 minus 3 times 0 over 0 minus 1 equals 2. Well, I know that 3 times 0 is 0, so that cancels out. And I get 2 minus 3a over a squared minus 1 minus 2 equals 2. Well, 2 take away 2 cancels away. And now, solving for a, I get minus 3a is equal to 2a squared minus 2 by multiplying both sides by my denominator. And so I get 2a squared plus 3a minus 2 is 0 by bringing the 3 over. Factor this. I get 2a, I want to get 3, so this is going to be 2. This will be a 1. Positive, negative, equal to 0. And so a is equal to 1/2, or a is equal to negative 2. Let's go back to our question for a moment. We know it's between 0, it goes from 0 to a, it's a positive value. So I am going to say that my a is 1/2.